joining our webinar. Good morning, good afternoon again. This is Kaustubh Jagtap, or KJ. I am the Director of Product Marketing here at SafeBreach. I wanted to thank you for taking the time to attend our research webinar today. Before we get started, there are a couple of housekeeping items that I do want to notify everyone of. Just a reminder that this webinar is being recorded and all registrants and attendees will receive a recording of this webinar via email. Additionally, this webinar, recorded webinar, will also be available on our website after today. At any given point of time, if you do have any questions about the content or the SafeBreach product, please send them to us using the Q&A functionality. We will be answering all the questions during the Q&A session. With that being said, let's go ahead and get started. So what is this webinar all about? On December 10th, two LDAP vulnerabilities were published on the Microsoft Security Response Center website as part of the latest Patch Tuesday update. An RCE vulnerability, CVE 224-49112, and a denial of service vulnerability, CVE 2024-49113, was published, which both affected the Windows Active Directory domain controllers. On January 1st, SafeBreach Lab researchers Or Yair and Shahak Morag released the first proof of concept exploit for CVE 2024-49113. This proof of concept is capable of crashing any unpatched Windows server, not just the domain controllers, with the only prerequisite being that the DNS server of the victim domain controller needs to have internet connectivity. That being said, today's research webinar shares this research, the rationale behind this research, and how our amazing researchers were able to create this proof of concept. Our presenters today include SafeBreach's research team rockstars Or Yair and Shahak Morag. With that being said, let's go ahead and get started. Over to you, Or.
Okay, just a second, I'll share my screen. So I hope you can all see my screen now.
Yeah.
Yeah, it's not the one with the notes, right?
No.
Okay, great. So hi everyone, we're so glad that you all joined us today to hear about our latest LDAP nightmare research, which, as KJ mentioned, is the exploitation research for CVE 2024-49113. This talk will be presented by myself, Or Yair, and by my colleague, Shahak Morag. So, this is me. I'm the security research team lead at SafeBreach. I have about 7 years of experience in the security research field. My past research included research on Linux, embedded, and some Android environments. And for the last 4 years, in my role at SafeBreach, I've been mainly focusing on vulnerability research in the Windows environment, which I just extremely enjoy.
Hi everyone, my name is Shahak Morag, currently serving as the research lead at SafeBreach, with over 6 years of experience in security research. My background includes extensive expertise in Linux kernel and embedded systems, with more than 1 year of focused research on Windows platforms.
Great, so let's see what we're going to talk about today. We'll start the talk with some of the initial background we had about the 2 new LDAP-related CVEs that were recently discovered by Yuki Chen. We'll continue with presenting the patch for one of these vulnerabilities and talk about the conclusions that we had moving forwards, looking to affect a domain controller to become our client. We'll see how we thought this can be potentially achieved, and we'll also see the DNS resolution obstacle that we had in the way for achieving that. Then the second part of the talk, we'll talk about the internals of the memory corruption vulnerability itself that happens in the vulnerable code. And finally, we'll end with seeing how LDAP nightmare can be simulated using the SafeBreach Validate product and with the takeaways from this research. So with that being said, let's begin. On December 10th, Microsoft released two critical CVEs, as KJ mentioned, titled with names related to the LDAP protocol. Both reported by Yuki Chen, probably together because of their following IDs, and both seemed very critical, with the RCE being the most critical one of the two, of course. Now, we decided that we will try to discover the exploit path required for these vulnerabilities, so the community will be able to validate its security posture against these vulnerabilities. But to start, we must first understand what is LDAP, right? In a nutshell, LDAP is the protocol that Microsoft's Active Directory uses to manage the directory services, meaning it is used to access and modify things like user accounts and similar resources. And now that we know that, we can look at Microsoft's CVE pages for the vulnerabilities. Now, looking at the CVE page for CVE 2024-49113, we couldn't find any extra information about it, but the page for 112 did provide some critical insights. From what was told in the documentation, from what Microsoft wrote, we can understand the following things. The first thing is that the vulnerability affects domain controllers, which is probably relevant for CVE 2024-49113 as well, but we cannot know that for sure. And second, it can be exploited by a remote and unauthenticated attacker, which sounds completely crazy. That means that if we can successfully exploit one of these vulnerabilities, then we'll be able to probably at least crash any domain controller that we can communicate with. So just think about the implications of that. Now, the third thing that we can understand from Microsoft's documentation is that in order to exploit the domain controller, we must find logic that triggers it to act as a client and do that using RPC calls. And then the last thing that we can understand is that the vulnerable process is probably LSAS, for those of you who know it, which is a very critical process in Windows. And that is because Microsoft said that exploiting the RCE can enable attackers to run code in the LDAP service, which is practically implemented inside of LSAS. Now, moving on, we needed to understand where the patch is implemented, because if we find the patch, we'll hopefully be able to understand the vulnerability much better. But then just before we started searching for it, we saw a very interesting tweet by Arthur Marzano showing a new condition added to the patched version. This patch was located in a function named LDAP chase referral. And then if the condition is met, it seems that Microsoft prints text that says that the referral number is outside of the referral table size. Now, we didn't know what the referral number or the referral table are at this stage yet, but it did very much seem like a fix for a vulnerability. Now, this patch was made in a DLL named WLDAP32, which we understood as Windows LDAP client library. But if this is a client library, could it be the patch for one of the two vulnerabilities affecting domain controller servers? Well, yes. If you remember, we already saw in Microsoft's documentation that the exploitation starts with turning a domain controller into a client. So a vulnerability in Windows LDAP client matches perfectly. If we assume that this is actually it, we can also assume that the process that eventually acts as the client is LSAS, as it is the process that were concluded to be the vulnerable process. With these conclusions, we moved forward to search for the RPC calls that were mentioned in Microsoft's documentation. The RPC calls that may turn a domain controller's LSAS process into our LDAP client. The requirement for these RPC calls are that they will not require any authentication, as we already read that the attacker can be unauthenticated. And the second thing is that they will have Active Directory domain related names or functionalities that will hopefully lead the domain controller to initiate an LDAP query to our malicious server. So we then listed all the RPC interfaces that LZAS offers and tried to filter for the relevant ones. Then two promising candidates came up. The first RPC interface was implemented in the NetLogon DLL, and the second one was implemented in LSA SRV DLL. Both interfaces contain Active Directory related functionalities based on the names of the RPC calls, and these calls seem to perform all sorts of enumerations, queries, and modifications related to an Active Directory domain. After searching for a few days, we found a very promising RPC call named DSR getDCName EX2. This function's goal is to retrieve the hostname of the domain controller of a given Active Directory domain. That's great. This really increases the chances that this is the right call, right? That is because the domain which is queried by this function is completely controlled by the caller. And it seems like this is the intention. Otherwise, the call would not offer the domain name as a parameter. At this point, all that was left to hope for is that the function retrieves the hostname of the domain controller of the given domain that is specified by the domain name parameter by sending an LDAP query, since we need the LDAP client to be the one contacting our malicious domain. We need this protocol to be the one that is being used, LDAP. We then of course, implemented a call to the DSR getDCName function, but the result was partially good and partially bad. On the one hand, we saw the victim domain controller actually issuing an SRV DNS query looking for the LDAP server in the domain that we provided for the call, which was sbresearch.lab. That validates that this function, this RPC function, really does use LDAP to fulfill its purpose, and that's great. However, the DNS query is not successfully solved. And why? Because why would we expect that the DNS server of the victim know sbresearch.lab? We are not a part of the same forest with the victim domain controller, so no DNS server of the victim knows us. That was so frustrating. We almost got there, but the victim DC just cannot find our Active Directory domain. But then a very important insight came up. While it is true that the DSR getDCName EX2 RPC function expects an Active Directory domain name to be provided, the DNS query that we saw being made cannot verify whether the query domain is actually an Active Directory domain or just a generic internet domain name. Once we understood that, the solution was very clear. We should just buy an internet domain name and set the proper SRV records in it to point to our attacker's server. And then the DNS server of the victim will know our domain. Now, SRV records are not very well known like other types of DNS records, but they are very simple to understand. As DNS records are basically mappings between one thing to another, SRV records map a domain name to another domain name and a port. So we created the exact SRV record that the victim DC was searching for, only that instead of doing that for the sbresearch.lab Active Directory domain that we used previously, we created this record for the generic internet domain that we now purchased, which is SafeBreachLabs.pro. And then as a final step, called the DSR getDCName ex2 function once again, but this time provided SafeBreachLab.pro, which is the generic internet domain, instead of sbresearch.lab, which is the Active Directory domain. And it worked. The DNS query was successfully solved, and the LDAP query was actually sent to our attacker server. As we're seeing in the slide, a CLDAP query was actually the one being sent, but CLDAP is just LDAP over UDP instead of over TCP. So that's still great. Now, what we can conclude from this part of the talk, the most important thing that we should remember for the second part of the talk is that we can basically turn any domain controller that we can communicate with to our LDAP client. So we can force the domain controller to contact and to query using LDAP any IP or hostname or domain that we want. But it's even stronger than that. And why? Because after taking another look at the DSR getDCName function, we saw that we can actually execute this function in any Windows server, not just domain controllers. So we can do that for any Windows server, meaning that maybe we can exploit the one of the CVEs that we're trying to get to in any Windows servers and not just domain controllers, as said in Microsoft's documentation. So with that being said, I'll hand over the microphone to Shachak to continue the second part of the talk, in which we'll see the internals of the memory corruption that happens after we trigger the DC to become our client.
Thank you all. Hi again, everyone. I hope you're all enjoying so far. Let's move on and finish the LDAP nightmare story. So let's get a brief introduction of the LDAP protocol itself. The protocol works on a client-server model. The client sends a packet with a message ID, such as a message ID of 5, and the server must respond with the same message ID, in this case 5, so the client can identify which response matches its request. The result code in the response indicates whether the server completed the request successfully. A result code of 0 means success, while any other value indicates failure. For this webinar, the other fields in this packet are not relevant and will not be covered. LDAP uses the TLV format, which stands for type, length, and value. The type field is strictly 1 byte in size and indicates the type of the value. The length field is also strictly 1 byte and specifies the length of the value. This information will be important for understanding the content of the next slides. Here we can see an example for this format. The first field is the type and has the value of 2. The second field is the length and has the value of 10. And the last one contains the value itself, SafeBreach. 2 indicates the type of the value here, and the length is the length of the string SafeBreach, which is 10. You can see it in X. To better understand the role of referrals in LDAP, let's explore how they function in a distributed directory environment. Referrals enable an Active Directory tree to be distributed across multiple LDAP servers. If an LDAP server cannot answer a request, it can respond with referrals pointing to other servers that might have the requested information. The client can then chase these referrals and send queries to the referred servers instead. The result code in the LDAP packet must be 10, which signifies the referral. Additionally, each referral must include a valid LDAP URL, meaning it should start with either the LDAP / or the LDAP / prefix. If neither of these conditions is not met, such as the result code not being 10 or the referral lacking a proper LDAP URL, the client will not invoke the LDAP chase referral target function, and the vulnerability will not be triggered. As we previously observed, the vulnerability is located within the LDAP chase referral function. Here we can see below a packet containing the spatial result code with the valid LDAP URL. As we talked before, WLDAP32 has the bug that's causing this exploit. So let's explore where the bug happens. To prevent attempting the same referral multiple times, the WLDAP32 client maintains a referral table. A referral is only checked against this table if the LM referral value is not 0, as we can see in the code here. We couldn't find any reference online regarding the meaning of the LM referral field, or how WLDAP32 extract this field. But we wanted to understand how this value is assigned and how we can affect it. Using IDA, we observed that LM referral is located at an offset of x3c from the start of the structure of the received LDAP packet. By searching for this offset, we identified two functions: LDAP initial decode message and LDAP chase referral. Upon further analysis, we found that only in LDAP initial decode message there is an assignment to LM referral variable, as indicated by the move instruction. Here you can see it in the red rectangle. This is the code responsible for deriving the LM referral value. The value in our packet must adhere to the following two restrictions. The value must consist of 4 bytes instead of 1 byte. If it has only 1 byte, shifting the value by 25 will result in 0. And the most significant byte must be an even number. Otherwise, the value will propagate into LM message ID, and the client will fail to match the response with its corresponding request. Do you remember that we've talked about the TLV format in LDAP? Now we can see why. To control the length of the value which the client deriving LM referral from, we need to set the length field to 4 instead of 1. So what does all of what I mean means? But we can set LM referral to be any number between 0 to 255, and LM referral can only be an even number. This is the summary so far. The referral table starts uninitialized, meaning that when WLDAP32 chases the first referral, no previous referrals exist in the table. The client does not expect the first response packet to have a non-zero LM referral value, as it assumes this value will only appear in subsequent referrals. This behavior causes the WLDAP32 client to crash when it attempts to access the uninitialized table. Since WLDAP32 runs within LSAS, this crash destabilizes the entire system, resulting in a sudden reboot. Here we can see in the red rectangle the access violation. So this is the maybe most exciting part of the talk. We'll now see the actual exploitation in action. We will see the domain controller crashes, and not only that, we'll see how we can use the SafeBreach validate product to simulate this attack, as we always do with our research project. On the right side of the video, we'll see the victim domain controller, and on the left side, we'll see the SafeBreach validate product that will be used to run the attack. So first of all, we'll need to get the IP of the domain controller in order to run the attack. Now we'll search for the attack in the management and duplicate the attack in order to put the IP of the domain controller. Now we will publish the attack. And now we'll create a scenario choosing the attacker that will attack the domain controller. Now we can see the IP of the attacker. So because we're using a generic hostname for the attacker in the simulation, we need to map this generic hostname to the IP of the attacker simulator. The generic hostname that we are using in the attack is SBAttacker, so we will map the SBAttacker to the attacker simulator IP in the etc host file. And now that we created the scenario, we will run the attack. We can see it running. And boom, we can see that we successfully crashed the DC, causing a blue window telling us that it will restart in 1 minute. Wow. And now we can see also in the management the result. We'll go to simulation results. And here we can see that the attack is missed, meaning the attack was successfully done and the DC has crashed, as we can see on the right side. Here also we can see in the simulation log what happened in the attack. And here we can see that the simulation was not blocked and successfully executed. And now we can see that the DC has rebooted after the ELSAS process crashed, as we talked before. And now, O will summarize the entire journey we've been through.
Great. So hi again, everyone. That's really cool, huh? Crashing any Windows server. That's completely nuts. But let's summarize all of this, starting with next steps. So after we published the LDAP Nightmare exploit, Yuki Chen tweeted that, and I remind you, Yuki Chen is the one that reported these original vulnerabilities. So Yuki Chen tweeted that the exploit that we published is exploiting CVE 2024-49113, which is the denial of service vulnerability of D2, which means that this is not the RCE one. On the other hand, in a related tweet, Yuki also mentioned that CVE 2024-49112, which is the one classified as the RCE, is less exploitable than CVE 2024-49113, even though it has a very high CVSS score. Which means that if we want to get a real exploitable RCE, it's probably not the way to go. However, what we're currently doing is that we're looking at what can be achieved using a DC crash, which is very interesting. But before we, like a few slides ago, Shahak showed you the maybe most exciting slide of the talk, and this is maybe the most important slide of the talk, and that's the takeaways. Let's understand what we can really learn from the mistakes that led to this vulnerability to exist. So the first thing that we think can be taught from this vulnerability is that we should not underestimate bugs in components such as protocol clients, for example, like the LDAP client, that seem like they can't be targeted directly by attackers. You can never know if there is a flow that will actually meet them. Second, since the LM referral value is not supposed to be set by the server in its first response, security controls can't detect this exploitation even without knowing the details of the vulnerability, and that's just by looking for abnormal behaviors in network communications, because we do know what should be the normal behavior in a normal LDAP communication. And that's not it. Lastly, setting the LM referral value to just any value in the first response was the cause for the crash. Therefore, you should always validate that all fields in a protocol can be set to any value in any state without having the program crashing. That's usually done by a fuzzer, but that can also just be done with some unit testing, or depends on the protocol that you're testing. But that would prevent this vulnerability as well if this was done before. Okay, so with that being said, with the most important slide of the talk, we can move on to giving you a link to the LDAP Nightmare repository. And you can also scan the QR code, which will lead you to the same link that you're seeing on the screen. We want to thank you all for joining us today. And we can move on to a Q&A session.
Thank you so much, Shahak and Or. At this time, we are open to taking questions about the vulnerabilities, the proof of concept. So please remember to leverage the Q&A functionality in Zoom webinars. We do have one question here. One of them is, we see this in Validate. Can this attack be customized, or can it be included in any of the existing playbooks, or does it have to be run on its own?
The attack must be customized in order to put the IP of the domain controller. Otherwise, the attack won't know which domain to attack.
Yeah, so usually what we do is that when we implement an attack between two computers, then we ask that simulators will be installed on both computers. But we understand that that can be maybe frustrating to install a simulator on a domain controller. And also, there's no real too much of critical side effects that we need to clean up after such an attack. So what we preferred with this attack is to allow you the possibility to just install one simulator, which is the attacker simulator, and then in the attack itself configure the IP that you want to attack with the simulator, the IP of the domain controller, and then you won't have to install a simulator on the domain controller that you're attacking.
Thank you. We have a second question. Is this attack provided for customers on SafeBreach platform?
Yeah. Yes. It is in the playbook.
Perfect. Any other questions? Are there any mitigations available in the platform to defend, or mitigations or recommendations, remediation recommendations available to defend against this attack?
So if you're talking just like generally, then generally we're not sure if there's something specific that we know to point to which will definitely stop this attack. However, if you want to develop your own detection or insert a certain rule, then we can point you to the fact that we think that the most critical evidence that can be detected from this, like during this attack, is the value of the LM referral value that is being returned by the attacker server. Because as we saw in the presentation, that value in the packet should always match the value that is being sent by the client. So if the LM referral value is returned differently than what it should, and we always know what the server should return, then somebody is probably trying to run the exploit.
Thank you. Do we have or can have an or extract the YARA rule created from this attack?
Do you mean in the product?
Yeah.
So, Shahak, do you know the answer for that?
No, I don't think that we have YARA rules for
I
this.
don't think so.
All right, I think that is about all the questions we have. Thank you again to everyone who attended this webinar and asked all these insightful questions. As I mentioned before, because this webinar is being recorded, the recording will be shared and made available on the website in a few hours, if not max by tomorrow morning. Thank you again for all the attendees, and thank you so much for Shahak and Or for providing us insight into this amazing proof of concept. Hope everyone has a wonderful day. Thank you. Bye-bye.
Thank you.